Okay, now let's take a look at why it's useful to extend derived types. Let's start from the top down. So we'll first write the main program. This is sort of the test-driven development approach where we write the test first and then write the code that satisfies that test. So first we'll make sure that we have to declare the types of all of our variables. And I'm going to imagine that we have a fluid module that contains a fluid type. And then type extension we usually use for subtyping. So you normally use it when you're defining something that is a special case of something else. So a special case of a fluid might be, for example, a compressible fluid. So we'll import this compressible fluid type. Let's declare a fluid. We'll call it air. And let's declare a compressible fluid. We'll call it compressible air. And for this simple demonstration, all we're going to do is print out some properties of the air and compressible air object. In particular, any fluid has a kinematic viscosity. Let's imagine that we have a type-bound procedure, and we'll see the syntax for creating such a procedure in a moment. And the type-bound procedure is named myKinematicViscosity. And I'm invoking it on the air object. That's what this percent notation means. What we're going to see when we implement the procedure is that the compiler will take this air object and actually pass it in. By default, it will be passed in as the first argument to the procedure. And since a compressible fluid is a fluid, we expect that it will also have a kinematic viscosity that we can print out. But in the specific case of a compressible fluid, we would expect it to also have another property called the bulk modulus. Okay. Now let's define the fluid module. So we'll open and close the module scope, prevent any implicit typing. And in object-oriented programming, we typically make all information private by default and only expose certain things. In particular, we're going to expose the fluid type so that the main program or any other modules that use this module can use the type. By default, that also exposes the data, but in object-oriented programming, we keep our data private. The data we'll have inside will be the kinematic viscosity. And I'm going to give it a default initialization. And then we're going to attach a procedure to this type. That's what enables us to call it using the syntax that we see in the main program. And we'll go ahead and implement this procedure in the module. Now we'll implement that procedure. It'll be a function that returns a value. And by default, this function is public because it's attached to the type. and we haven't done anything to make it explicitly private. I mentioned that in the main program, the compiler will pass the object air in as an argument, by default the first argument, to this procedure. I call the argument this because that's what it would be called in most other object-oriented programming languages. And the result from this procedure will be the kinematic viscosity. I'll just call it viscosity here. Because this procedure is type-bound, we're required to declare the argument, which is called the passed object dummy argument. We're required to declare it with the keyword class instead of the usual keyword type. I'll specify here that it has intent in, meaning I won't modify it. What the class keyword does for us is it enables us to, at runtime, pass in an object that is either of the fluid type or of any type that extends the fluid type. And we'll see how that's useful for us in a moment. And the result that we're going to return is the kinematic viscosity component of this fluid object. Now we'll implement the compressible fluid module. Open and close the module scope. Ensure that we have to give all of our variables a declared type. By default, we'll make everything private, but we will expose specifically the compressible fluid type. Now let's pull in the fluid type into this scope. The reason we're doing that is because the compressible fluid type extends the fluid type. What that does is, effectively, it's as if we had an extra component here that is of type fluid and also happens to be named fluid. And that's the parent type to our compressible fluid type, which therefore means we have inside here a kinematic viscosity. But we don't have to actually write that because the compiler will put that there for us automatically. What we will do is add the new data we want, which is the bulk modulus. And then we'll add a new type-bound procedure that can return the bulk modulus. And again, we've given the bulk modulus a default initialization so that even just upon declaring it, that value will be there without us doing anything special to assign to it. And let's implement a function that returns the bulk modulus. Again, there will be the passed object dummy argument. We'll call it this. Again, because this procedure is type-bound, we have to declare it with the keyword class. This ability to pass in different types into the same argument is referred to as dynamic polymorphism in object-oriented programming. And the result that we return we'll simply get from the corresponding component of this type. Now we'll save this and compile. And run the program. What we can see here is that first we print out the kinematic viscosity for both the fluid and compressible fluid, and then we print out the bulk modulus for the compressible fluid. And looking at the main program, what's interesting is that when we made that call to my kinematic viscosity and invoked that procedure on the compressible air object, the call went into the fluid module because we never implemented my kinematic viscosity in the compressible fluid module. What happened was the compressible fluid type inherited that procedure from the fluid type. And because, as I mentioned, the compiler inserts a component inside every compressible fluid that is a fluid object itself, what we're effectively doing is calling this procedure on that fluid object that is the parent of and inside the compressible fluid object. So the value of type extension then is that we don't have to re-implement this procedure. We can inherit both the data that's inside the fluid parent object and the procedures that are attached to that fluid parent object.